All right, lesson 4-3, we are using linear models to make predictions. There's two ways to do this. You can either just look at the graph and make a prediction based on the graph. That's example 2 that we're going to get to in a minute. Or example 1 here in a minute that we're going to get to is when you can't use the graph to make a prediction because the predicted number is too far off of your graph. So if you look at this example, we've got calories burned over time in minutes. That's what our axes are named. And our y-axis is the calories burned. And the question is, how long would someone have to work out? So the question is the x, right? How long would they have to work out to burn 5,000 calories? Well, if you look at how high the calories burned goes, it only goes up to 900. We're not even close to being able to see 5,000 calories on this graph. So we have to go about it a little bit different way, but it's a review. We have done this before, okay? The way we do it is we have to write an equation in y equals mx plus b, and then we plug in either the x or the y to solve for what they're asking, okay? So in this case, we need to first draw a line of best fit. So if everybody would go ahead, I've already drawn mine, but if everybody would go ahead, I can delete this and we can kind of start over here. The first thing you want to do is draw a trend line or a line of best fit. You'll hear it called either thing. It means the same thing. It's just the line that best fits with your data. So sometimes it's called a line of best fit. You'll hear that a lot in algebra at the high school. They refer to it a lot as a line of best fit. And your curriculum refers to it as a trend line. So I'm going to, and it would make sense that 0 time burns 0 calories. So I can kind of start there and just run my line up through my data, okay? Now, everybody's trend line is not going to be identical, but that's okay. They should look fairly close. You can't have something crazy, but it should be fairly close. Now, we know to write an equation, what do we need? The two things we need to write an equation for a line. We need an M and a B. We need an M and a B, okay? The B is very easy to find. It's where does your line cross the y-axis? And the way I drew it, it crosses at 0. Now, you don't have to necessarily, you could have started it up a little bit, but mine crossed at 0. When you're doing your homework, not everybody is going to have the exact same line of best fit, which means not everybody is going to have the exact same equation. My B is 0. Your B might be 5. Okay, your B might be 10. My slope might be 10, your slope might be 11. Are they really, really close? Yes. Does that mean the lines are almost identical? Yes, and that's okay. So if everybody had the exact same answer, I would be concerned, okay, because you shouldn't. Everybody's trend line or line of best fit is going to be just a hair different. All right, so in this case, for the one I drew, my B is 0. Now I need to find an M. We know to find an M, we need to pick 2 good points. Well, I definitely like that point as a point. And then I like this point as my next point. To find slope, it's rise, turn the corner, run, right? And I know it's going to be positive because my line's going up. So how much do I rise from my first point up to my second point? Yeah, I rise 100 over, then I turn the corner and I run from here to here. And what's my run? 10. And so when I reduce this, I get that my M equals 10. So I have an M and a B. I can now write an equation, which is what I've done here. Y equals mx plus b. Okay. Now the question asked was how much time would you have to exercise, and time is x. How much x time would you have to exercise in order to burn 5,000 calories? So when y is 5,000, what is x? That's what the question is asking. Go ahead. And I think it helps to actually write that. Up here where it says, how long would you have to exercise to burn 5,000 calories? I think it's very helpful to say, how long would you have to exercise? That's your x. That's what you don't know. In order to burn 5,000 calories, which is your y. I think it's very helpful to write something like this because it keeps you straight on what you have and what you don't know yet and what you're trying to find out. So when I have an equation y equals 10x plus 5, and I want to know when y is 5,000, what is x, I can simply plug 5,000 in for y. And that's what I've done in this next line. I've plugged my y of 5,000 in to solve for my x to know how much time I have to work out in order to burn 5,000 calories, right? Find my x with my given y. So when I do that, I divide both sides by 10 and I get x equals 500. And so my answer to my question is 500 minutes. I would have to work out for 500 minutes in order to burn 5,000 calories based on my slope. So that is what I mean by there's some overlap. In topic 3, we learned how to write this right here, right? We learned how to write an equation in y equals mx plus b by finding the m and finding the b. And we did a little bit of plugging in to solve in topic 3. We were given some information, either the x or the y, and we solved for what we weren't given, either the x or the y. And we're going to be doing the same thing here. All right, so if you look at example 1, this is what they've done. Now, something I want, if you have a highlighter or if you just do it with your pencil, but I want you to highlight or underline the words at the same rate. Michaela is a speed skater, hopes to compete in future Olympic Games. She researches the winning times over the past 50 years. If the trend in faster speed continues at the same rate, why is that wording important? Anyone? Why is it important that it's at the same rate? It's going to be constant, which means I can make a prediction based on if it's constant, it means my graph is a straight line. If my graph is a straight line, I can write a linear equation with an m and a b, and then I can find or make predictions. So it's very important that it's at the same rate. At the same rate means linear. Just come use this if you need to. At the same rate means linear, which means it has a slope. If it has a slope, we can find the m, we can find the b, and we can make predictions, okay? You can't make a prediction if it's all over the place, right? If it changes every single year and it's up and it's down and it's all over the place and your graph's a curved mess, you can't make a prediction. But if it's a nice straight line, you can make a prediction, okay? And that's what we're going to be doing. All right, it says, how can she use the information to predict what might be the time to beat in 2026? So the first thing we have to do is we have to write an equation for our trend line, right? Because it's linear, it's at the same rate. That tells us it's linear. We can draw a trend line. And once we have a trend line, we know if we have an m and a b, we know we can write an equation, okay? And that's what we're going to be in search of. Now, something I want to point out, and this is the biggest error I see every single year when we get to this point in algebra and in pre-algebra, is we want to know the time to beat in 2026. So a lot of times people will plug in 2026 for the x. Notice the x-axis is not just the years, it's the years after 1960. So if we want to know 2026, we're not going to put 2026 on our x-axis. We want to know how many years after the year 1960 is 2026. So we got to do a little bit of calculation. How many years is it to get from 1960 to 2000? 40 years. How many years is it to get from 2000 to 2026? 26, which adds up to 66. So on this line, right, this would be 60. 66 would be somewhere out here. Now it's off the graph, so we can't use the graph to make the prediction. So we're going to have to write an equation to make the prediction. But it's really important to note that your x-axis is not the number 2026. You have to watch this wording right here. It's years after 1960, which means on the graph, this represents 1970. This represents 1990, right? This represents the year 2000. So you really have to be careful where 2026 would fall. Okay, that's one thing. The other thing is you have to write an equation. And we know to write an equation, we need an m and a b. Well, here's our b right here. So the b is very easy to find. You just look at the graph and you say, where does your line intersect the y-axis? And the answer to that is 2.4. So we have the b. We have to find the m, and that's what they've done right here, right? Your m is your rise or your fall. It's going to be a negative number because it's falling. It's going downhill. And then you're going to turn the corner and you're going to run. And they've already done that for us. They've said that the fall was negative 0.2, and they said the run was 15. Right? That's where they got this right here. This is where they're figuring for the slope. This is the m equals. Now, I know I've told you, and it stands true most of the time, you can leave your slope as a fraction because it's rise over run. And if you're going to have to graph it or do much with it, it's nice to just leave it as a fraction. For this indicator, or for this section, it's really going to be helpful to go ahead and make it a decimal. Okay. And if you want to make yourself a note, I am only requiring you to go out to the 100th place or 2 decimal places. So convert your fractions on this particular homework assignment. Convert your fractions to decimals. And then you can round to the second decimal spot or decimal place, okay? And normally I say leave them as a fraction. Normally that's better, but in today's assignment, because you're going to be plugging it in and using it to solve, it's going to be helpful to have it as a decimal. So that's what they've done, okay? They've converted it right here into a decimal. And then, so for our sake, for what the homework is, we're saying that our m equals, and that's what they found right here. That's our m. So negative 0.0133. So they wrote an equation right here. Y equals mx plus b. That's what they've done there. They wrote an equation in y equals mx plus b. And this is the m right here. And this is the b. Okay, they wrote the equation using the m and the b. Now we need to make a prediction. So to make a prediction, you take your equation, which is right here, y equals mx plus b, and we want to know, when we've already figured this out, we want to know 66 years after 1960, right? So our x that we want to know about is what's going to be the winning time. We want to know the y because winning time right here, winning time is y. We want to know the y when x is 66 or 66 years after 1960. So we take the x of 66 and we plug it in for the x in the equation. There's the x in the equation. We plug 66 in for the x because we want to know, right? And what are they asking? They're asking the time in minutes, 66 years after 1960. And so if you multiply your m times 66 and then add your b, this is where they come up with 1.5222. So 1.5 minutes, and you can either write that as 1.522 minutes or 1.5 or 1 minute and 30 seconds, because 1.5 minutes is 1 minute and 30 seconds, and it doesn't matter which way you write your answer. And notice the reason we had to do it this way right here, which is mathematically, is because our graph did not go as far as 66, right? Our x-axis didn't extend out far enough. Now, if you look in example, oh no, let's do the try it first. All right, so now let's do the try it, okay? For the try it, we want to know, it says, assuming the trend continues, which means stays the same, use the equation of the trend line to predict average gasoline in 2025 or miles per gallon in 2025. So the first thing we have to do is we have to use our graph to find our m and our b, right? Well, the b is easy. That's the nice one. Here's 12. Here's 18. We've already done it, but halfway in between is 15. Okay, if you're not sure, add 18 plus 12, divide it by 2, and you'll get 15. So our b is where our line begins on the y-axis. So our b is 15. To find our m, we need to pick a second good point. Well, I think this is a nice good point. I like it because it's right on the intersection of 2 grid points. And then I need my rise over my run. I turn the corner. It's rise over run. How much do I rise? From 15 up to 18, how much do I rise? 3. And then I turn the corner and I run how much? From here to here is a run of what? It's 2 blocks, but what does it represent? 10. And because I know I'm going to need this in an equation, I'm going to go ahead and put 3 divided by 10 in my calculator and get 0.3. So I now know that my M is 0.3, so I can plug that in right here. Y equals MX plus B, and I said my B was 15. So I've written an equation. Now it wants me to make a prediction about miles per gallon, so I'm finding my Y, right? I don't know my Y. What is the Y when X is what? Well, you cannot put 2025 in for your X because your X is not your year. Your X is your years after 1980. So to get up to 2025, how many is it from 1980 to 2000? 20 years. And then to get up to 2025 is another 25. So I want to know what the miles per gallon is or what the Y is when X equals 45. So I take my equation that I just wrote, which is right here. Y equals 0.3 times X of 45 plus 15. Take a minute to work that out. All right. So we take 0.3 times 45 and we get what? What'd we get? Riley, what'd you get? 0.3 times 45. Everybody should be working this out. Everybody should have a calculator, punching it in right now. 13 point what? Is that what everybody got? Okay. And then we got to add 15 to that. So what's our final Y equal? Who haven't I heard from? Dalton, what's my final Y equal? 28.5. And what that means is that in the year 2025, miles per gallon is expected to be 28.5. So that's what we would plug into that box. Okay. All right. Now let's look at it. Example 2, these are so much easier because what we were looking for in the earlier example didn't fit on our graph. What we're looking for now does. So when you're given a scatter plot, the first thing you want to do is draw that line of best fit or that trend line, which is what they've already done right here. Okay, that's step 1. Then you want to read what it is you're looking for. It says about how many people should the owners of the park expect at the water park when the temperature is 90? Well, these are really nice because 90 is right on our graph. We don't have to do any math. We follow our eyes straight up from 90 to our trend line. We turn and make the corner, and there's your answer. So when the data fits on your graph and you can make a prediction based on your trend line, very nice and easy. Okay, no math needed. Okay, they're expected to have about 800 people when the temperature is 90 degrees outside. Okay. This last part is interpreting. Now, when you see the word interpret, what should you write above there? When you see the word interpret, what should you put above there? Anybody know? Real world answers. Okay, real world. Everybody write that on there. So when it wants you to interpret what the slope or the rate of change, that's this first one, what does the slope or the rate of change represent in this situation? You can't just say rise over run. Yes, that's what slope is. But in this story, right, what does it mean? It means that, and it says it right there, right? You're comparing the number of smoothies purchased over the temperature. So you're looking at the rise in the number of smoothies purchased when your temperature rises. So that's why it describes the number of smoothies purchased for each degree the temperature increases. When it asks you to interpret it, they want in this particular graph, what does it mean in the real world? Okay. Same thing when it asks you to interpret the y-intercept. What does the y-intercept represent in this situation? Well, in this particular situation, it means the number of smoothies sold when the temperature is what? Yeah, say it out loud. 0. For this particular story, it wants to know that what your y-intercept represents is the number of smoothies sold when your temperature is 0. Okay, so when you're interpreting, notice I use the words temperature and number of smoothies purchased. It's kind of like that describing the relationship. It's using words from the graph to tell a story. Okay. All right. And then it says what equation relates the temperature to the number of smoothies sold. Well, that means you got to find your M and your B. Anytime it says right here, anytime it says, what's the equation? Oops. What's the equation? You know you're going to need a what? What do you need when it asks for the equation? Every time. What do you need to write a linear equation? M and a B. There we go. Anytime it says what is the equation, you know it's an M and a B. Okay, you have to find it. The B is easy. You just look and see where does your line start on the y-axis. The answer is 8. For the M, find 2 good points. Okay, find 2 good points. I would say use the B. And then another good point is right here. That's another good point. So you would rise, you would turn the corner and run, and you would build your M and build your B. And in this case, the B is 24, or the M is 24 over 40, which reduces to 3/5. And you can, if you're not going to have to do anything except write the equation with it, you can leave it as a fraction. If you're going to have to make a prediction, I would change that 3/5 to a decimal if you're going to have to make a prediction with it, which means you're going to have to plug something in. Make sense? Okay, that is all I have for you for notes. For those of you at home, the homework assignment is the Math Excel 4-3. And for everybody in class and at home, this is one where you're going to have to turn in work paper, because look how much work goes into finding your M, finding your B, and then making predictions. So I need to see that work. If you're making a prediction and you don't just make it from a graph, I need to see your find your M, find your B. I need you to build your equations and then predict. Okay? If you have any questions at home, shoot me an email.